Hi guys, welcome to this quick recording, basically to help you guys with your project. What I have in here, I have GeoGebra. For you, you might have an actual paper, basically graph paper. So you can use that. So I'm going to use GeoGebra in here to help me basically with the project. So the first part in here, it says to draw a circle. So I'm going to draw a circle centered on the origin of radius 10 units. So for your case, it's going to be 10 units on your graph paper. So for here, it's going to be 10 all the way around. So I need to probably minimize this one to look at 10 from the top and the bottom. And it's going to be a circle basically centered in the middle. So I have negative 10 in here, positive 10, negative 10, and positive 10. So it's going to be a circle of that size. For my case, I'm going to drag the circle from the center, which is 0, 0, and drag it all the way to 10 units. Okay, obviously, this is probably slightly more than 10 units. Let's check in here. The radius is square root of 99, which is almost 10. So actually I can make it perfect by dragging the point B, right? And it's centered on 0, 0. So I'm going to drag the point B in here so that it makes that number exactly 100. Or I can actually come in here and see if I can make this. There is another way of doing it, honestly, that is. Okay? And it's still not correct. It doesn't have to be exact, by the way. This is a project. So actually, let me see if I can nail it in here, and it's exactly 100, okay? I really don't need the point B, so I'm going to hide it, and I don't really need the center also. Actually, I need the center, and I will tell you why, because that's supposed to be the sun. So I'm going to change the label in here and call this one sun, and hit anywhere, and that is where the sun is supposed to be, the center. This is the path of the Earth. So another change I'm going to make to this path, which is, in this case, they call it C. So I'm going to change the color just to indicate that it's a blue, just in reference to the Earth. That's all. So at this point, we're done. I really need to import something in here, and that is the image. So I'm going to get the image that I need, and I believe, let me check in here. If not, let me browse for it. And it's in here. I need a protractor because you will see that we will need the protractor to find the location of the Earth and Mars. Basically, I'm going to make it a little smaller. And before I do that, there is another thing I need to draw, and that is the vernal equinox from the Sun extending far away past the orbit of the Earth. So I'm going to drag it to about 20 points. For that, there is a tool in here called the segment. So I'm going to draw a segment starting from where the sun is, and that is point A, by the way, starting from A and extending all the way to, let's say, for example, a point of coordinates 20, 0. So that is on the x-axis. And let's see here if it does it. And it did indeed draw for me this equinox. Let me change the settings. Let me push it a little bit further, and you will see shortly why. I'm going to drag it all the way to the point 30. I know you can't see point 330 only. Okay. Oops, why is this? Let's write 30. I'm sorry, I have a small keyboard. So, okay. So if you look at it, it's actually extending up to this point. Okay. And that's good enough for right now. So I'm drag everything a little bit to the side in here. And that is basically, for your case, you may drag it not too far, okay? I really don't like the way that this has labeled it. So I'm going to come in here and write its name. It's the vernal equinox. That's what it's called. And I'm going to take this vernal equinox and move it out of the way a little bit, okay? And so we're going to draw everything in reference to the vernal equinox. So if you look at the instructions in here, let me find them, if I can find them. In here, basically what I have the position of the Earth on March 21st, 1931 with respect to the vernal equinox. So it's 180 degrees. The vernal equinox is at 0 degrees. So I need to use a protractor to find 180 degrees, and it's going to be this point. Okay, so that's the position of the Earth on that date. When we looked at Jupiter on that date, I'm sorry, Mars was at 118 degrees with respect to the vernal equinox. So I need to move the protractor to this position and look for 118 degrees and draw an arrow, because if I'm looking from the Earth to where Mars is, I really can't tell what it is, at least in terms of depth, but I can find the angle for it with respect to a special direction, and in this case is the vernal equinox. So I have 118 degrees, I draw a ray from that point, and then on another basically Martian year, that would have correspond to February 5th, 1933. On that date, the Earth would not be in this position. Okay. Remember, March 21st is actually the spring equinox. Okay. So this is going to be a little bit still in the winter of 1933, almost 2 years later. Mars would be in the same position in the sky, but the Earth would have shifted and the angles now shift. So now if I draw another ray from there, I will know exactly where Mars was on that date, either March 21st or February 5th, 1933. I will know exactly where it is because the intersection of these two lines will give me a specific point, and that's going to be the first position of Mars. So let's do that. March 21st, 1933, it's 180 degrees, so it's easy to find. But just to help you out, so I'm going to use a protractor. I'm going to line it up on the sun, take this point and drag it a little bit out. Okay, make sure that this is centered on the sun, and it is, and it's parallel to the vernal equinox. Okay, you have to make sure that it is still parallel to the vernal equinox. So in this case, 180 degrees. So if I zoom in a little bit, and sometimes you have to be a little bit careful because your alignment might not be exactly perfect. So make sure that it's aligned, meaning that the zero passes by the vernal equinox. So, and it does, okay? And also it's centered on the Earth, on the sun in this case, okay? Because you're looking from the direction of the sun from Earth. And Earth then it's 180 degrees according to the table. Here is the table again. The Earth on March 21st, 1931 was the opposite of that axis. Okay, so we're going to take a point and we're going to draw that point on that position of the Earth on that day. Okay, and that point now has some special properties, which we're going to call it the position of the Earth on that day. I'm going to just call it E1 for Earth 1. Okay, and I'm going to change the color for it in this case because the Earth is going to be blue. Okay, so we have one point in this case, and that point is called E, actually. That's how GeoGebra in this case called it. But you might label it. It doesn't have to be labeled for your case, but it's a good idea to label so that because at the end you will have a bunch of points. So you have to keep track of that. Because if you look at the table in here, you have 16 points. Okay, you have 8 data entries in here, and each one corresponds to 2 positions of the Earth, and each one of them corresponds to 2 sightings of Mars on that day, and Mars will have a unique location. So at the end, you will have 8 positions for the Mars and 16 positions for the Earth. So I'm going to start from E1 to E2, E3, all the way to E16, but Mars at the end will have positions, I'm going to call it M1, M2, M3, all the way to M8. Okay, so let's continue. So we have one thing, but then on that date, when the Earth was in that location, E1, Mars was at a position of 118. So I'm going to move the protractor and put it the center in here, put it on the Earth, put it in position E1, line it up with the vernal equinox, and look for the angle of 118 degrees. So let's do that. I'm going to again use the selection tool and move this thing a little bit down. So I'm going to take the protractor and position it on the Earth, keeping it parallel again to the vernal equinox. So that's easy, okay? Now I'm going to take the selection dot in here, the drawing of points in here, okay? And I'm going to find the angle. Remember, it's 118 degrees. So I'm going to go from 0 to 90 to 100, 110, 120, okay? But then this is 110, this is 115, 116, 17, 18. So the point is going to be here. Okay, I need to shift it a little bit because it's a little bit toward the 119. And I think that's perfect. Okay, so it's called point F. It doesn't matter. At this point, it's just a reference point. I'm going to draw an array. So let me move this out of the way because I really don't need it now. Protractor. Okay, so I'm going to draw an array, a line of sight from the Earth looking at Mars on that date. So there is a function in here good enough as nice as it has it, called ray, and the ray starts from a point, which is E actually, and extends passing the point F. Okay? So this is my line of sight. I really don't need the label in here too. I don't need to see the label, but that's fine for right now. Uh, Let me go to the settings in here and not show the label either. Okay? And so I need just a line in here. At the end, we're going to erase it after we basically make use of it because this is our line of sight. On the next date, which is February 5th, 1933, the position of the Earth is 136 with respect to the vernal equinox. So I'm going to go on that date. Again, I'm going to move this protractor on the sun, centered on the sun, and find 136 degrees. 136 degrees. So let's do that. Again, the selection tool, this is 130, starting again from 0. You have to be careful when you start your reading, always in this case from the vernal equinox, because you have other numbers on the top of protractor. Every protractor has numbers from the top and the bottom. The top are actually reading from this side. I'm not looking from the opposite to the vernal equinox. I'm looking actually from the vernal equinox. So it's 136 degrees, 136 degrees. This is 100, 120, 130, 140. This is 135, that's 136. So my point is exactly past 135 by 1 point in this case, and it's going to be this point. Okay, actually, let me select it and move it slightly. It's still like a perfect. Okay, and that is actually the position of the Earth on that day. So I'm going to come in here and change its name to E2. Remember, I was calling the positions of the Earth, E1, E2, all the way to E16. So this happened to be E2. Let me get the protractor out of the way for right now. So this is the position of the Earth on that day, February 5th, 1933. It's 136 degrees. On that day, Mars was at 168 degrees from the vernal equinox again. So I'm going to take this protractor, put it on the Earth on that day. Remember, if you're using this, you have to make sure that the axis of the protractor is parallel to the vernal equinox in this case. Okay, it's very important. So that's why you drew it actually in the first place. If in doubt, just draw another line in here that is parallel to that one and align your ruler to it. Align this line to it. Where it says 0 in here, align it to that line that is parallel to the vernal equinox. Okay? And from here, it's easy. I'm going to find the angle. The angle is 168 degrees. So this is 168 degrees. Again, I'm reading from the start of the vernal equinox, which is this axis, by the way, parallel to the vernal equinox, and then start reading 150, 160, 170. This is 165, 66, 67, 68. Let me draw that point again. This is 165, 66, 67, 68. So this point. Okay, and that point actually is another point for right now. So let me move this thing out of the way. So remember, I'm starting from E2, which is in this case point G, and extending to point 8, H, and I'm going to draw another ray, okay? And where the two rays intersect is where actually Mars was on that day. So I'm going to come in here and draw a ray again that starts from the point G and extends to the point past the point H, and it's that ray. Okay, hit enter, and I really don't need its label. So at this point, in going to properties, I don't need to show anything about this line. I know its name is H, and the other ray's name is G, because I need to find where these two intersect, and that is the position of Mars. Let's recapitulate. On March 21st, 1931, when we looked at Mars, we saw that it's making an angle of 118 degrees. So it could be anywhere on this line, on this ray. A year, a Martian year exactly, which is 22 months, just 2 months short of a year, about 2 months. It's about less than 2 months, actually. It's not exactly 22 months. The Martian year is slightly more than that. Mars appears on February 5th, 1933, exactly one full revolution around the sun, one full, basically, rotation around the sun. When the Earth is actually on February 5th, is actually here, 1933, it appears to be making an angle of 168 degrees with respect to the vernal equinox. So it could be anywhere on this line. The intersection of these two lines is exactly where it's supposed to be. So, because it was all along in here. So when I looked at it on that date, I saw it in here, on this line. When I looked at it on the second day, I saw it in here, after a full Martian year. So again, in this case, it's going to be what? Intersect of these two rays. And the first ray is G. This is case sensitive, by the way. And the second ray is lowercase h. And it's going to give me a point. It labeled I. I don't care about what it labeled. I'm going to go and change its settings and call it M1 for Mars 1. M1. And I'm going to change the color for it because Mars typically is red. And at that point, I'm done with that piece of entry. So I'm going to come in here, erase this ray. I mean, not erase it, honestly. So let's just not see it, hide it. Erase, hide the point H, hide the point, the ray G, and hide the point F. So that's all there is to it at this point. For your case, when you're drawing this on a piece of paper, draw it with the light. Don't push too much on the pencil, so that when your time comes and you really don't need that line, you're going to basically erase it a little bit, because you will have a bunch of lines at the end of the day. Remember, we draw the vernal equinox, and that we're going to keep. But you could potentially have drawn another line that is parallel to that, and that is going to be a little bit too much then. And then there is another line in here, and there another line in here, all of which is just to get that position of Mars on that date. So there is a bunch of points. And imagine you have to do that 16 times, basically. So this drawing is going to be complicated. Let me erase this C in here. I mean, let me get rid of the C in here. And that is this curve in here. So I'm going to, that's the path of the Earth. So I don't really want to see that too. I mean, the less things at this point, the better it is. So let me just, for the sake of argument, I'm going to take another date. It doesn't matter. I'm going to take entry 7. It doesn't matter at this point, like I said. And I'm going to draw the points. For entry 7, it's going to be the Earth is 178. So on March 19th, 96. So remember, I have done M, E1, E2, E3. So now I am E12, E13, and E14. So those are the two things that I'm going to draw. So 178 degrees with respect to. So I'm going to draw this. We'll bring this one in here and put it on the sun and find 178 degrees. So this is 170, this is 180, so it's just 2 degrees above that. So that's the position of this the Earth. By the way, you might be thinking, okay, let me just, to avoid this issue in here, pick up another date. Pick up entry 5, okay? That would be 9 and 10, okay? E10, E9 and E10. So 60 degrees. So let's get out of that side in here, okay? Because we are too close from the other entry in here. So for entry 5, the Earth is at position 60 on November 22nd, 1941. So 60 degrees on that date is here. So that is 60 degrees smack on the dot in here. Okay, so that is going to be 60 degrees. Okay? So that is the position of the Earth. Remember, we called this one, it's going to be E9 settings. So this is going to be E9. That's my convention. You don't have to follow it. And on that day, the position of the Mars is at 12 degrees. So let me go back in here, take the protractor, and move it to the position of the Earth. Again, keeping it parallel with respect to the x-axis. Okay, right, smack in there. So in this case, it's 12 degrees. This is 10. So let me drag the point in here. This is 10. 1, 2, that's 12 degrees. Okay, so that is a position of at least the line of sight where potentially Mars is. So this whole thing is going to be the direction where Mars is. Again, I'm going to draw another ray here. Ray starting from E9, and E9 happened to be J, extending to the point K. Okay, so that's a ray. Okay, GeoGebra called it I. Then on the next October 10th, 1943, the Earth was at position 17 degrees with respect to the vernal equinox. So again, I'm going to put it in the center in here. We could have left it in the center and do all of the positions, 16 positions of the Earth, but that's fine. So the Earth in here is on position 17 degrees. So 17, you have 10, 15, 16, 17. Okay, called it L. And let's call this one now E10. So we're going to call this one E10. Okay, that's the position of the Earth on that date, which is happened to be October 10th, 1943, 17 degrees. And Mars is actually at position 80 degrees. So again, I'm going to take the protractor and move it to the position and keeping it parallel with the vernal equinox and finding the position of 80 degrees. 80 degrees is smack in here. So I'm going to draw. So this is 80 degrees exactly. And at this point, that's the position of basically the line of sight where these two lines intersect is actually where the position of Mars is. Okay, so in here I'm going to draw a ray first, ray that extends from L to M. Okay, let me get this thing out of the way because it's still in the way. Okay, so where the two intersect is going to be the position of 9, since we're already on the 5th point, so I'm going to call it M5. So the intersect of these two rays, intersect of the ray is J and I. So I, comma, J, and hit enter. And that is N. So I really don't want to call it N. I'm going to call it M2 first of all. Not M2, I'm sorry, M5, because this is the 5th entry. And the color, I'm going to put it red. Now I don't really need to see this rays and these points and so on and so forth. So I really don't need to see J. I don't need to see M. I don't need to see I. And I don't need to see K. Okay. So now I have basically, I assume that you guys can continue and finish the table, the entries in here, and you're going to find different positions of Mars using the protractor and ruler, of course, for your case, because I have GeoGebra. In this case, I'm not using ruler, but I assume that you guys can have a ruler to draw the vernal equinoxes and the parallels to it, and also the rays and where the intersect is, where you're going to find the entries for the position of Mars. You're going to have different entries, so it's going to extend to about 16 entries, and at the end, basically 16 entries for Earth, so that's why I call them E1, E2, all the way to E16. In this case, I drew only 2 entries, E1 and E2. And for the 5th entry in the table, I also drew the positions of the Earth in this case and in this one. So I assume you can finish the rest in here using protractors and a pencil and a graph paper and also a ruler. And at the end of the day, you should be able to locate all the positions of Mars on those dates using that table. When the second recording I'm going to post, I'm going to have the finished product and how it looks like, and basically how you connect all of these lines to draw your final settings. Sounds good? Thank you.